So the next topic will focus on two-stage completion methods for either of the previous stages to finish. So this is basically like a logical OR operation. And again, there's a couple of different variants of this. We're going to focus on except either. And as you can see, except either is going to perform some action when either of two previous stages completes. And so you could think of this as basically a logical OR. So if either one finishes, the computation gets run. This particular example returns a future to void, which means that there is no return value that comes back. It's basically a one-way operation. And here's an example of how we might do this. This is a pretty clever example. This is a great example of what you can do when you have lots of cores. So if you have lots of cores, you can afford to be core consumptive and use cores sort of willy-nilly. And here's a good example of how to do that. So I'm sure you remember from your algorithms class that there's a bunch of different ways to sort lists. You have quick sort, you have merge sort, you have bubble sort. There's lots of different sorts. And one of the questions that theorists tend to ponder, smoking a pipe or something and thinking deep thoughts, is which is the better mechanism in which circumstance? Fair question. And the answer is we don't always know, because it depends on certain factors. It depends on, is the data ordered, all kinds of interesting things. So we don't really know ahead of time whether merge sort or quick sort will win. So rather than sit there and scratch our heads and perform some kind of complicated algorithmic analysis, why don't we just try both approaches, and we'll run quick sort in parallel with merge sort. Fair enough, right? We got lots of cores. Why not? So what we're going to do is we're going to start them both up, and then we're going to call the except either method. Remember, this is the one that's the logical OR. So we give it the quick sort completable future and the merge sort completable future, and we say, whichever one of these things gets finished first, we'll take those results. So that's the way this is going to work. That's the big picture view. And the thing to notice is that even though whoever finishes first will take the results, we're going to let the other computation complete. We just ignore the results. So except either does not cancel the second future after the first one completes. And there's good reasons for that. Most notably, that future may be needed for some other computation. That result may be needed for something else. So we don't want to unilaterally cancel it. So we'll show some examples of this later. But for right now, just be aware that the results here will be printed out when either of these two things finishes. And what we're going to do, as you can see, is when we get the results back, we're going to say, for each of the results, go ahead and print the results out as a mixed string or whatever. OK, so that's just a simple illustration of how the concept of the logical OR variants of the methods works. And there's a couple other methods that do this type of thing, but they're all just related to what we just showed here. OK, so that is the end of this